Good day. So our lesson for today is about theorems involving properties of parallelograms. And here are the learning objectives. First, illustrate the theorems on the different kind of parallelograms. Second, proves theorems on the different kinds of parallelogram. And last, proves the midline theorem. Here are the core values. We have understanding, accuracy, effectiveness, and efficiency. Okay, so before we start, let's define first a midline. So what is a midline? Okay, when we say midline, it is a special type of a triangle or it is a part of the triangle. It is segment joining the two midpoints of a triangle, just like in this given illustration. We have triangle CDE and points A and B are the midpoints of segment CV and CE. And AB is the midline of the triangle. Let's have the midline theorem. When we say midline theorem, it states that the segment joining the midpoints of a triangle is parallel to the third side of the triangle and is one half of its measure. So you can see the proving on page 148 to 149. Let's have the illustration. So we have here triangle CDE and the midline is AB. In this theorem, it states that the segment AB and the third side DE is parallel. And we can say that the measurement of the midline or segment AB is equal to the half of the measurement of segment DE. So for example, if the measurement of the midline is 8 centimeter, to get the measurement of DE, just multiply 8 by 2. So 8 times 2, we have 16 centimeter. Okay. And if the given is the third side, for example, we have 18 centimeter as the measurement of the third side. So what is the measurement of AB? So here, just divide the measurement of the third side by 2. 18 divided by 2 is 9 centimeter. Okay, let's have another example. So determine the measure of the variables given that AB is the midline. For letter A, we have here the given measurement for the third side, which is 16 inches. And we need to find the value of x, which is the midline. And we have here the given measurement of two angles. We have 64 and 32 degrees. And we need to find the measurement of z degrees and y degrees. So here's the solution. First, since we have here the third side, the measurement of the third side, 16 inches, to get the value of x, divide 16 by 2. So we have x is equal to 16 divided by 2, and the value of x is equal to 8 inches. And for the second one, as you can see, we have here the alternate interior angles. And according to the Paik theorem, alternate interior angles are congruent. So the measurement of y degrees is also equal to 64 degrees by Paik theorem. And next, the z degrees. As you can see, we have here two given measurement of angles. And the total measurement of the angles of a triangle is equal to 180 degrees. So all you need to do is to add these measurements and subtract its sum to 180. So we have angle Z is equal to 180 minus 64 plus 32. And the value of Z is equal to 84 degrees. Okay. And for the next one, let's have Letter B. As you can see, the midline is also segment AB. And we need to find the measurement of the third side given that the measurement of the midline is 7 centimeter. And also we need to find the measurement of k degrees given the measurement of angle 25 degrees since it is a right triangle, so the measurement of this angle is equal to 90 degrees. And for the legs, we have to find the measurement of these two segments, 3n minus 5 and n plus 9. Okay, so here's the solution. First, we need to find the value of p. So to get that, just multiply 7 centimeter by 2. So we have p is equal to 2 times 7, which is equal to 14 centimeter. And for the next one, since this is a right triangle, k degrees and 25 degrees are complementary angles, meaning the sum of these angles should be equal to 100, I'm sorry, should be equal to 90 degrees. So to get that, k degrees is equal to 90 minus 25, which is equal to 65 degrees. And last, to get the value of n and the measurement of these segments, since this leg has its midpoint, which is B, meaning this segment is congruent to the other segment. So we can equate it. 3n minus 5 is equal to n plus 9. Then combine like terms, we have 3n minus n is equal to 9 plus 5. Simplify it, we have 2n is equal to 14. Divide it by 2. So the value of n is equal to 7. And substitute the value of n to the given. So we have 3 times 7 minus 5 is equal to 16. Write the unit centimeter. And for the other segment, 7 plus 9 is equal to 16. Copy the unit centimeter. Okay. So next example, Bea wants to determine the length of the quadrilateral chord pattern if the vertices lie on the midpoint of the rectangle whose diagonal is 10 inches. What is the perimeter of the quadrilateral? Okay, let's illustrate this problem. We have here the quadrilateral chord pattern C, O, R, D. And for the second statement, if the vertices lie on the midpoint of the rectangle, so the midpoint of this, we have Q, U, A, and L. And then connect this one, and it formed a quadrilateral. So we need to find the perimeter of this quadrilateral using the measurement of of the diagonal of a rectangle, which is equal to 10 inches. So we have diagonal CR is equal to 10 inches and diagonal OD, which is also equal to 10 inches. Okay, so how are we going to find the measurement of these sides? Let's use the midline theorem. So as you can see, it forms a triangle. We have triangle CDR. So the diagonal will serve as the third side of this triangle. So CR is equal to 10 inches. What would be the measurement of its midline? UA. Okay, very good. This is 5 inches because 10 divided by 2 is 5 inches. And for the previous theorems we have discussed, so the opposite side are congruent, meaning if UA is equal to 5 inches, then the measurement of QL is also equal to 5 inches. Okay, so we need to find the two measurement of these sides. So to get that, we can use another triangle in this illustration. Okay, let's have the diagonal OD. Okay, so the in this triangle ODR, the midline is LA. So if the measurement of this diagonal 10 inches is 10 inches, meaning the measurement of its midline is equal to 5 inches. So we have AL is equal to 5 inches. And for the opposite side, which is QU, since they are congruent, so the measurement of QU is equal to 5 inches. Then to get the perimeter of this quadrilateral, just get the sum of the measurement of its sides. So 5 plus 5 plus 5 plus 5 is equal to 20 inches. So here's the complete solution. Thus, the perimeter of the chord is 20 inches. Okay, so let's have the next one. Let's define intercepted segments. When we say intercepted segments, these are formed from distinct lines cut by the parallel lines. So, what are these? Okay, let's have this illustration. Given that lines CD and E are parallel, and we have lines A and B as the transversal of this in this given illustration, we can say that QR is congruent with RS and QU is congruent with UV. So these are the intercepted segments. So let's see the theorem behind it. It is the intercept theorem, and it states that if parallel lines cut a transversal into congruent intercepted segments, then they intercept congruent segments on any of its transversal. So you can see the proving on page 149 to 150. Okay, so here's the illustration. So in this given, since QR is equal to RS and TU is equal to UV, if the measurement of QR is equal to 10 centimeter, meaning the measurement of RS is also equal to 10 centimeter. And another example, if the measurement of UV is equal to 5 centimeter, the measurement of TU is also equal to 5 centimeter. And if you will find the measurement of TV, just get the sum of this. So 5 plus 5 is equal to 10 centimeter. Okay, so let's have another example. We have here this illustration. So LO is parallel to BT and BT is parallel to AE and AE is parallel to SK. So given that LB is congruent with BA and BA is congruent with AS, in the figure, determine the measure of the following. So let's have the first one. If LB is equal to 8 inches, and KE is equal to what? I'm sorry, 5 inches, what are the measures of LA and OK? So we need to find this one, LA and OK. So what are we going to do? Okay, so here's the solution. First, to get LA, since the measurement of LB is equal to 8 inches and LA has two segments, so multiply it by 2. 2 times the measurement of LB is equal to 2 times 8. So the measurement of LA is equal to 16 inches. And for letter, for OK, OK is equal to thrice the measurement of KE, which is equal to 3 times 5, and OK is equal to 15 inches. Okay, next. For letter B, if OT is equal to 2x plus 3 and TE is equal to 5x minus 12, find the measure of KT, or I'm sorry, KE plus KT. Okay, so here's the given OT, 2x plus 3, and TE is 5x minus 12. So using a theorem, we can say that OT is congruent with TE. So we can equate it. So we have 2x plus 3 is equal to 5x minus 12. Then combine like terms, so we have 3x is equal to 15. Then divide it by the coefficient 3. We have x is equal to 5. After that, substitute the value of x to the given. So for OT, we have 2 times 5 is 10 plus 3 is 13. Then write the unit if there is. OT is equal to 13 units. And since OT is congruent with KE, we can say that KE is also equal to 13 units. And to get the measurement of KT, since KT has two segments, so we have 2 times the measurement of KE, which is equal to 2 times 13. So the value of KT is equal to 26 unit. So to get the measurement of it, just combine this one. 13 plus 26 is equal to 39 units. Okay, and that's all for today. I hope you learned something. Thank you and God bless.